Hello everyone. This tutorial will be about high voltage transformer for generating AC high voltage. First, I would like to show you a single unit of high voltage transformer. High voltage transformer is simply a step-up transformer used to step up the low voltage supply, such as 220 volts, to very high voltage, up to 300 kilovolt. This high voltage will be applied then to the specimen or insulator to be tested. However, you should understand that this transformer is not the same as high voltage power step-up transformer that is used in electrical power system or used in substations. Our transformer is called high voltage testing transformer, used only for high voltage testing in high voltage labs. Now, let's see the construction of the high voltage testing transformer. First, we have the iron core of the transformer. 2 is the primary winding or the low voltage winding of the transformer. 3 is the secondary winding or the high voltage winding of our transformer. The high voltage winding is connected to the high voltage electrode here. This high voltage electrode is then applied to the insulator to be tested. We have also a bushing insulator here to isolate between the high voltage electrode and the earthed body of the transformer. We have also the grounded metal tank and base, and also we have the insulating tank. Also we have a field grading shield for uniform distribution of the voltage across the high voltage winding. Now let's see the operation of the high voltage testing transformer in our lab to test the insulator. First, voltage is increased gradually through any type of voltage regulators until breakdown occurs. When breakdown occurs, the voltage at which the insulator breaks down is the breakdown voltage, and this voltage can be measured by using any high voltage techniques for high voltage measurement. We know also that high voltage insulator is always considered as a capacitor loads. Why insulator is considered as a capacitor? Because it is a dielectric and it's also placed between two electrodes or two conductors, high voltage electrode and the earth electrode. So this is a representation of the capacitor. So we can represent the insulator here by a capacitor, and it's called CT. While CT is the capacitor of the insulator, and it ranges from 10 picofarad to 10,000 picofarad. Now we want to get the kilovolt ampere rating of the high voltage transformer. Now we want to get the rating of the transformer to be designed. The rating of the transformer is Pn, while Pn in kilovolt ampere. So how we can find the kilovolt ampere rating of the transformer? We know that Pn equals V square over Xc from this circuit, while V is the voltage of the high voltage side of the transformer, while Xc is the reactance of the insulation. We know that Xc equals 1 over omega Ct, while omega is the angular frequency and Ct is the capacitor of the specimen or the insulator to be tested. By substituting the value of the Xc in this equation, we find that Pn, the rating of the transformer, equals V square omega Ct. But we should take into consideration another compensation factor K due to the wiring and additional capacitance effect. This is for safety factor. Thus, the power rating of high voltage transformer, after taking into consideration the compensation factor, Pn equals V square omega Ct times K, where V is the nominal RMS voltage of the high voltage testing supply, so high voltage side of our transformer, while Ct is the capacitance of the equipment under test, and K is a factor or safety factor for additional capacitances within the whole circuit and some safety factors, and K should be bigger than 1. Also, we have omega is the angular frequency, while omega equals 2 pi f, and f is the frequency of the supply, which is 50 hertz or 60 hertz. As our transformer produce a high voltage AC but at power frequency as explained before. So this is a complete understanding for our high voltage testing transformer and how this transformer can be used in the lab to produce very high voltage AC at power frequency.